Okay, here we're going to solve the CPCTC worksheet basically by matching corresponding parts. So we can see that 15 matches with H. We can also see that 38 degrees matches with A. For here we want to find out what X is. This is going to be a triangle sums problem. So we have 125 from 180 is going to give us 55 degrees for the measure of X. That should be 125. Which gives us 55 degrees. For number 4, 3 y's is 21, so y is going to be 7. For number 5, basically it's going to be triangle sums. We've got 84 plus 52 plus x is all going to add up to 180 degrees. So that gives us x plus 136 is equal to 180, which means that x is going to be 44 degrees. Or A is going to be 44 degrees, rather. So doing the vertical angles, we can jump all those angle measures around. We get the triangle sums, and A is going to be 44. Looking at number 6, we want to find out what P is. We can easily see that P goes with 4. So 13 plus P goes with 4 plus 18. 22 is equal to 4 plus P. Take away 13, we get P is equal to 9. This number 7, X is going to be 41. Because you can see that those are corresponding angles, or alternate interior angles. Here we want to find out what y is. Y is obviously equal to 7. That's kind of like a no-brainer. Let's look at these proofs. We want to prove that n is the midpoint. So if we can prove that an is equal to nb, or segment an is congruent to segment nb, basically we've got n is the midpoint. So that gives us n is the midpoint. That gives us a side, and then we got the other two sides given to us. So it's going to be a side proof. We need to get everything in there. So AN congruent to NB is given. And then by definition of midpoint, we can say that the two segments are congruent. We got the other given. We also need that NX is congruent to BY. And by side, the triangles are congruent, and then the two angles are congruent by corresponding parts. For this one, RT is congruent to RV, and TS is congruent to VS. So the other RS is going to be congruent to itself by reflexive. That sets up side for this proof. So we need to get our given in there. RT is congruent to RV. And I guess on the next line, we could use our next given, which is that TS is congruent to VS. And by the reflexive property, we have RS is equal to itself. And get the TS equals VS in there. It's side pattern. Our triangle RTS is going to be congruent to triangle RVS. And then by corresponding parts of congruent triangles, CPCTC, those two angles are going to be congruent. Looking at number 3, they're telling us that VB bisects both of those vertex angles, the one at B and the one at V. So what that's going to do is give us angle 1 congruent to 2 and angle 3 congruent to 4. And with BV reflexive as the included side, it's going to set up an angle side angle pattern. So VB bisects EVO is given. By definition of angle bisector, we get angle 3 is congruent to angle 4. I started thinking 1 was congruent to 2, but it's actually 3 congruent to 4. And then our other given is that VB bisects angle EBO, which is going to give us angle 1 congruent to angle 2 by definition of angle bisector also. And then BV is going to be congruent to itself. So that sets up an angle, side angle pattern for us. And we can say that the two triangles BEV is congruent to triangle BOV by angle, side angle. And then their corresponding parts are going to be congruent by CPCTC.